Hi guys, welcome back to YouTube channel Chemistry Live UGPG. So today we are going to talk about separation of sugars using paper chromatography. So this will be highly useful for BSc and MSc chemistry students under CBCS syllabus. So I have a simple message for you. Always be think for innovation, always be creative and learn smartly everywhere, anytime and help to learn others. So there is a disclaimer for this experiment. So in this experiment, approximate data are used to give a flavor about the real experiment, calculation part and conclusion and better understanding about the experiment to the students. So if you carry out your own experiment, you will get your own original data for your experiment and it may happen that result may vary from person to person. So the aim of the experiment is separation of sugars using paper chromatography. So what are the apparatus required? Beaker or chromatography chamber, glass plate for covering the beaker, Wattman filter paper, fine capillary tube. Chemicals required. We need glucose and lactose. Then solvent is ethyl acetate, pyridine and water and mixture of isopropyl alcohol and water. So we need to know first what is the basic principle or theory behind paper chromatography. So paper chromatography is a simple method for separation of mixture of compounds, may be colored or colorless, on the basis of their different rates of migration across a sheet of paper. So in paper chromatography, the adsorption column is the filter paper. So when the filter paper containing a mixture of compounds is placed in solvent chamber, the compound will move along with the solvent in upward direction due to capillary action of the solvent. The compound of mixture will be separated due to different rates of movement in different substances. If compounds are colored distinct spots are observed. If compounds are colorless, locating reagents are used depending upon the compound. So this is the actual procedure we need to follow. So first we have to prepare the mobile phase. A mixture of ethyl acetate, pyridine and water was prepared. And for staining reagent, 0.5 gram of metaphenylene diamine and 1.2 gram of stannous chloride was dissolved in a mixture of ethyl alcohol and acetic acid. Then preparation of a stationary phase. So here stationary phase is paper. Wattman filter paper was cut into a sheet of paper of size 20 cm into 5 cm. A horizontal line was drawn on it with a pencil at a distance about 2 to 3 cm from one end, and a dot mark was drawn on the middle of the line and was encircled. Then application of the sample onto the paper. So a mixture of two sugars were prepared and in isopropyl alcohol and water in a ratio of 10 is to 90 in watch glass. Then fine capillary tube was used and it was dipped in the solution of sugar and spotted on the mark on the paper and dried in oven for 5 minutes. Then development of paper chromatogram. A tall beaker with cover was taken as chromatogram chamber. To that 25 ml of solvent mobile phase was added. Then watch glass was used to cover chromatogram chamber to prevent evaporation. The spotted paper was dipped in the solvent mixture of beaker carefully so that the spotted mark remains just above the level of solvent and sides of the beaker do not touch the paper. The beaker with spotted paper was covered by watch glass and allowed the solution to rise above by capillary action. After 5 to 30 minutes, once the solvent front reached the top of the paper was removed and marked the position of solvent front by pencil and dried in oven. Then detection of spot. The dried paper was taken away from oven and this paper was dipped in the staining solution or locating reagent. Then the paper was dried at 100 degrees Celsius until dark yellow spots appeared. And the distance of solvent front and yellow spots from the baseline was measured. And the same procedure may be repeated for 2 to 3 times for better separation. So here is the diagram. Here you can see the baseline and at this point the spot was given where the mixture of compounds was put by using capillary, and when we allow the solvent to travel and the compound A traveled this much distance and compound B has traveled this much distance, and this is the distance from baseline solvent front around 14 cm here. So suppose we spot colored compound, so we can see how much distance each colored compound has traveled and the distance traveled by the solvent front. So here we have to note down the data in the form of a table. So the sugar glucose has traveled the distance 6.2 cm and the lactose has traveled 4.4 cm and the distance traveled by the solvent front, let's say 10 cm. So RF value found to be 0.62 and 0.44. So how to calculate this RF value, let's talk about. So what is RF? The retention factor, which is a measure of position of particular compound in a chromatographic separation. So in formula, RF equal to distance traveled by the compound divided by distance traveled by the solvent. So RF of glucose equal to 6.2 by 10 equal to 0.62 and RF of lactose equal to 4.4 by 10, that is equal to 0.44. So in conclusion, the RF values for two sugars, glucose and lactose, in the mixture was found to be 0.62 and 0.44 respectively. So I will be happy if you guys subscribe our channel Chemistry Live UG and PG. So this is a simple step towards e-learning, making life better. Thank you all for learning.